if we have 3 points which are non-collinear. Non-collinear means the points which are not on the same straight line. Then if I join them, what happen? We get a shape which is close, flat, and bounded by 3 lines. Okay, this triangle, this shape we call it triangle. Then here you see tri mean 3, so it will have 3 sides, 1, 2, 3, and also 3 this point we call vertex, and at the same time we have this corner we call as angles. So based from this, triangles have 6 elements. That means 3 angles and 3 sides. Okay, so based on those we will have also 6 type of triangles. If all sides are equal, we call it equilateral. 2 sides equal, we call it isosceles. No side equal, we call it scalene. Then if one angle is 90 degree, we call it right. One angle more than 90 degree, we call it obtuse. And if all 3 angles are less than 90 each, then we call it as triangles, acute triangles. So we know that in a triangle, if we plus all 3 angles, the sum will come to be 180. So now let us try to compare the triangles. We'll try to compare them. Then to see what kind of triangles they are. So first, before we start that, we are likely to get with this term congruence. Congruence means equal in everything. When I say equal everything, mean equal in the size of the length of their side, and also equal in angles. So for that, let's see first for line segment. 2 line segment, they are said to be congruent if and only if their length are equal. Suppose we have this line segment whose measure is 4 cm, another one also 4 cm. So their length are same. That means we say they are congruent. Then the same thing for angles. You may have 2 angles. Then if you measure here, if you get 60 degree, here also 60 degree. Then in that case, we call them to be congruent angles. Okay, then the same way for triangles, they will be congruent if, suppose I take this one, I put it upon here. Okay, like our hand like this. So if I put, you can see, if I put my left hand on right hand or right hand on left hand, you cannot see the other. Okay, so that means they are exactly equal to one another. So then in that case, we call them to be congruent, and this is a symbol for congruence. So that means if we have 2 separate triangle, then if we compare their side as well as their angle, maybe this one is 3 cm, here 3 cm, then this one 4 cm, here also 4 cm, 5 cm, 5 cm. Then if you get this one 60, here also 60. Then if you get this one is 50, here also 50. Then if you get here 70, there also 70. So in such a way that if we put this one here, they will be exactly same. Length also equal, angle also equal. So in that case, we set them to be congruent, and we use this symbol equal with this one. That means all 3 sides and all 3 angles are equal. So 2 triangles are said to be congruent if and only if one of them can be made to be superimposed. That means we put one upon another and their size are everything equal. So in such a way that if we put one upon another, we cannot see the other, okay, because everything is the same. So that is what we call as congruence. Then to prove that the triangle congruence, we don't need to prove all 3 all 6 condition. Okay, we don't need all 3 sides or all 3 angles. If we get at least 3 of those conditions, then we will say they will be congruent. So if the 2 triangles are congruent, then their corresponding part are equal. Corresponding part mean the part which are more or less in the same position, that we used to call as CPCTC. Okay, because like here, if we have that mean triangle ABC congruence triangle DEF, then it mean that side AB equal to DE, BC, EF, because they are correspond, AC equal DE, and at the same time angle A equal angle D, angle B equal angle E, angle C equal angle F. That is what we are talking about, corresponding part are equal, or in short we should write CPCTC. Those. Okay, so let us see the criteria for the triangles to be congruent. So like I told you, triangle has 6 elements, but not necessary to prove all the 6. At least if we can get 3 of them are equal, then it's enough for us to say that the triangle are congruent. Okay, so there is time we may not have the angle, we may have only the side. So like this one equal to this one, that is the side S. Then this one equal to this one, then S. This one equal to this one, S. So if we have those 3 side are equal, then the triangle are congruent by side congruence theorem. Okay, then there is time we may not have the side, we may have 2 side. This one we may not know, then instead of having the third side we have the angle, this 160, the 160. So then in that case it will come SAS. So 2 separate triangle whose 2 sides are equal and 1 angle, then that we will say SAS congruency. Or sometime we may not know the side, but we know only one side, that is S. Then we know this one 50 equal 50, 70 degree. So in this case we know 2 angle and 1 side. Then in that case also we can say the triangle are congruent by ASA. But if we have only angle without side, then in that case they may not be equal, because sometimes the side may be one longer, one shorter, but angle are still equal. But if the reverse happen, if all the side equal, then the angle are bound to be equal. So those we have to see. Okay, if you have SSS or SAS or ASA, then in that case we can conclude the triangle are congruent to each other. But if we have AAA, then it may not be the case. So like here you see we have 2 triangles. Okay, they will be congruent. If we see like this, we have AB equal to DE, AC equal to DF. Then we have these 2 side, they meet at angle A. These 2 side, they meet at angle D. Then in that way that these 2, they are equal to one another. Okay, and this angle, it is made by these 2 equal sides. So in that case we say the triangle are congruent by side angle side congruence criteria. Okay, because we have 2 side and included angle of one triangle equal to 2 side and included of another triangle. The angle should be between those 2 equal side. Then in that case we say the triangle are congruent by SAS or congruence criteria. So using that we can prove this theorem. Angle opposite to 2 equal sides of a triangle are equal. So from the statement you need to see the given. What is given here? A triangle. Then also in that triangle we have 2 sides are equal. Then that you can write as given. Okay, triangle you can draw, you can name. So here we name the triangle as ABC. We take AB equal AC. That is the given part. Then what we have to prove? The angle which are opposite to these 2 equal part, they must be equal. So if we look from the figure, okay, if we look from the figure, then we have AB. So opposite to AB we have angle C. Then we have AC. Opposite to AC we have angle B. So that means we have to prove angle B equal to angle C. We have only triangle, we cannot do much, so we already know SAS, so we try to divide the triangle into two parts. So what we have to produce ourselves, we write in the construction. We draw AD as a bisector of angle A. When I say bisector, bi means two, sec means cut into two equal parts. So they cut this angle into two equal parts so that we get two triangles. One is ADB, another is ADC. So here we have AB equal to AC already given. Angle BAD equal angle DAC from the construction. Then if you see this side AD, we will find it in ADB as well in ADC. So in such a way that means here we have the side, here we have the angle, here we have the side. So we get two side and one angle are equal, which means these two triangle, they are congruent. So once they are congruent, the remaining angle will be equal. So that means angle B will be equal to angle C, which prove what the theorem wants.